Hi everybody, welcome to another video in Trigonometry, section 4.2, Amplitude and Period. Amplitude. Definition, let the function be a periodic function. Suppose m is the maximum values of f and m is the minimum values of f. The amplitude is defined to be the average of the maximum and the minimum values. An example of that, if we have a function is equal to sine or cosine, let's say sine of x, the graph of sine x that is the graph of sine x is bounded between -1 and 1. So the maximum values is 1, the minimum values is -1. The difference of them is 1 minus -1 is 2, and half of that is 1. So the amplitude is the distance from the middle to the maximum or to the minimum. So the amplitude is, in this case, is equal to 1. So that is an example of an amplitude. And we have this theorem, the function y equal to a sine x or a cosine x have the amplitudes of a, absolute values of a. So if we have negative, then the amplitude still the amplitude is always a positive number, so it's going to be an absolute values of that. Okay, we'll go to an example when we have a negative case. And only sine, cosine have amplitude. The other function do not have any amplitude. Right. And after that, in this section, we're just going to graph a lot of function. But keep that for now. Now let's go to the second part. We do a lot of example all together. The period. Now, recall that the function sine x, cosine x, secant, cosecant have the period of 2 pi, tangent and tangent have the period of pi. So normally, for all of those functions, tangent and cotangent period is a pi, sine, cosine, secant, cosecant, the period are 2 pi. We did this on the previous section. This is just a review. Now we have a theorem. If we have a function, the graph, if it is a periodic function, a period p, the graph will have the same shape as that, but the period is going to be p divided by b. For example, if we have the sine, cosine, secant, cosecant, it is instead of we have b times x, so the coefficient times x, then the period is going to be the default values. So for sine, cosine, secant, and cosecant, the standard is 2 pi. If we have a coefficient multiplied by x, the period is divided from 2 pi. The default value, the standard period for tangent and cotangent are pi. If we have something multiplied to x, the period will be that number divided from pi. Of course, where we have the b or b multiplied to x, and that is the period. Right. We will do together in the graph later, but for now, it's very important that we review everything we know in this, all of the properties of trigonometric function. Right. I put this at the end of section 4.2. So let's zoom out. Right. and yeah, okay. So now we review all the properties and characteristics of trigonometric function. First, the domain. By the way, it is just from the previous section, so I'm just going to write it out. So the domain of sine, cosine will be the same. It is from -1. I mean, all real numbers. The domain of sine, cosine will be the same, the whole number line. Those two will be the same. Now, for tangent, secant and cosecant, tangent, cotangent, secant, cosecant, we'll get back to that because that have to depend on some other function. But for sine, cosine, that's what we have for the domain. For range, it is bounded by -1 to 1. So on the graph is from -1 to 1. Right, we talk about all of that later. Alright, so that's what we have. Now, what else can we get from this? Remember the period, sine, cosine, secant, cosecant, the period are 2 pi. Tangent and cotangent, the period is a pi. So I'm going to put the period for sine is 2 pi, 2 pi for cosine, 2 pi for secant, 2 pi for cosecant. Only tangent and cotangent, the period is 1 pi. Right? What else do we know? Also from previous section, even and odd. Even. Only cosine and secant are even. Everything else is odd. So cosine is even. Reciprocal of that is even. Everything else is odd. Just a review from previous section. Right. Now, tangent, we define properties or identity. Tangent is sine over cosine. Cotangent is cosine over sine. Secant, 1 over cosine. And cosecant is 1 over sine. Now, that is very important. Now, the next step we go into is the 0, which is very important. When sine is equal to 0, if we have a unit circle, when sine equal to 0, sine is the y values. The y value is equal to 0 is on the x-axis, so we talk about these values, which is a multiple of pi. So 0, pi, 2 pi, 3 pi, negative 2 pi, and so on. and then the cosine equal to 0. Cosine is on the unit circle associated to the x values, and the x values will be on the y-axis. So x equal to pi over 2 plus k pi, where k are integers. Now, a lot of the graph will depend on this. For example, the domain, tangent sine over cosine, secant 1 over cosine. If cosine equal to 0, the function is undefined. So the tangent and secant, those two, the domain will be x not equal to pi over 2 plus k pi. Because if that equal to 0, cosine equal to 0, it is undefined. Same thing here. On the other hand, if cosine, cotangent cosine over sine, or 1 over sine, if sine equal to 0, then the function is undefined. So for cotangent, x is not equal to k pi. Of course, k's are integers. We don't have to write them again. Now, not only that, if it is not equal to 0, it is in the domain. If x equal to pi over 2 plus k pi, the cosine is equal to 0, and the function is undefined. The function is undefined, but it will have the asymptotes there. So the domain and the asymptote are opposite. By opposite, I mean one is equal to and one is not equal to. So asymptote will be equal to pi over 2 plus k pi, pi over 2 plus k pi. And once again, cosine over sine, or 1 over sine, if sine equal to 0, it is undefined. But we have the asymptote there, so x equal to k pi. That is where sine equal to 0. Right. And because the function sine cosine defined everywhere from negative to infinity, there is no break in the function. There is no gap in the function. And the function have to have the point where there is a gap. There will be the asymptotes. Since there is no gap in the function, asymptote, there will be no asymptotes for sine cosine. Right. So where the function is not continuous, for the trig function, if the function is not defined at that point, it will be the asymptotes there. So because it is defined everywhere, there is no asymptotes. When it is not defined, there will be the asymptote. So those are kind of one equal to, one not equal to. Right. A lot we can get from this also. Now, tangent is sine over cosine. So when the top equal to 0, the function equal to 0. So when sine equal to 0, so we have x equal to k pi. And here when cosine, the top equal to 0, cotangent equal to 0. So x equal to pi over 2 plus k pi. So most of the domain, the asymptotes, the zeros, will depend on these two. So that's very important that we know these two. They can imply a lot of this. Right. I continue. What else do we get from this? The range from the previous section. tangent and cotangent on real numbers. So the whole line. And the range for secant and cosecant are everything but 1. So if I draw the number line, -1, 1, it will be on the outside. So we can write -infinity to -1, union 1 to infinity, -infinity to -1, union 1 to infinity. So the range for these two will be the same. These two will be the same. And these two will be the same. Right. Now, the amplitude is directly related to it. Because the graph is bounded between -1 and 1, the amplitude will be 1. In this case, for sin x is 1. Because it goes from -infinity, there's no maximum, no minimum. This function do not have amplitude. And also, because the secant and cosecant, the domain is not including 0, so it cannot be 0. So that we almost complete the table, right? So the domain and range, of course, for sine, cosine, and then the range. This what we need to know. But this part here is the most important. When sine x equal to 0 and when cosine x equal to 0, this will deduce a lot, implies a lot of things, including the domain of the others, because we define based on the quotient. If the bottom equal to 0, it is undefined. Now, if it is undefined, there will be the asymptotes. So that also based on this too. Right. And finally, the characteristic of the graph. For sine, we talk about this. For sine, the pattern is going to be, I'm not sure we have enough space, but middle, max, middle, mean, and then to the middle. So middle, max, back to middle, go to mean, and then go to middle. So that is the pattern of sine. For cosine, cosine is that. Oh, I shouldn't draw that, just based on the one period from 0 to 2 pi. Okay. The pattern of cosine is max, middle, mean, to the middle, and then back to max. Tangent and cotangent. tangent is the tangent axis is this. So the bigger the angle, the bigger value. So original tangent is 0, and then just keep increasing. So the values just keep increasing. So the tangent is increasing throughout. And cotangent is decreasing. And secant and cosecant. Secant is 1 over cosine, so it will bounce up the maximum and minimum of cosine. So I'll just say it. Bounce off the maximum and minimum of the reciprocal function. Secant is 1 over cosine, so this is reciprocal of bouncing up the maximum and minimum of cosine. Likewise, for cosecant, it would be bounced off max and min of sine. Right, so keep this handy. We'll refer this back to this many times. And besides, you should bring out a bunch of this before taking a test. Just fill out this table. That is very good review, very good practice. Right, now we'll get back to the section and do a lot of examples. Let me zoom back in. Right, now we're going to graph. Now, notice that the amplitudes and the period here are for the standard sine x and cosine x. Here we have a little bit different. Right, so it says here, sketch this graph 2 sine x. Now the function y equal to a sine x or a cosine x, the number 8. Take the absolute values of that, give us the amplitude. So that is the first thing we do, is find an amplitude. Absolute values of that. So that's the first thing we do. We know the function is bounded by 2 and negative 2. So just draw 2 and negative 2. Once we know the amplitudes, we go directly wrong. That. So the graph will bouncing between these two lines. Next, the period. The period for sine and cosine, the period is 2 pi. So we're just going to choose 2 pi to be period. So if we choose 0, and once we choose the period, we divide a period into 4 equal pieces, because after that we're going to fit the parent. We're going to fit the parent into the graph. So 1, 2, 3, and 4. So that will be 2 pi. The other side, 1, 2, 3, and 4, negative 2 pi. So once we know the period, we do that and divide that into 4 equal segments. So this gives us 1 period. And the rest is easy. The pattern, what is the pattern for, or the characteristic of the sine? It's going to be middle, max, middle, mean, and back to the middle. So one period for sine is that. And I will just copy and paste this to the whole number line. So that is y equal to 2 sine x. Easy enough, right? So we note the amplitude, so where the graph bounded by the period, the length of a period. Usually we just choose that and then divide that into 4 equal pieces. Now if we divide that to pi, this will be a pi, and then half of that is pi over 2, 3 pi over 2, and then so on. So we have the graph. It's just simple as that. Next, y equal to negative cosine of 3x. So first, of course, amplitude is going to be absolute value of whatever numbers in front of the function 3. So it's bounded by 3. And of course, we can just choose 3 to be anything. Now, say here's 3. Two, 1. Okay. So 3 meaning that the amplitude go 3 up, 3 down. The period for standard cosine is going to be 2 pi. So again, I divide that into 4 equal segments. And that gives us 1 period. And then the parent. Of cosine of x. The parent of cosine of x is start from maximum, middle, minimum, back to middle, and go to the max again. So that is pattern of cosine of x. However, in this form we have the negative. So we have to turn everything to pretty much flip everything. The pattern of negative cosine of x. Of course, if it is the maximum, we throw the negative. It flips it down and it becomes the minimum. So max become mean. Middle is still middle. Minimum becomes max. Middle still middle. Max become mean. So those are the parent corresponding to 4 equal increment on a period. So we start from minimum, middle, max, middle, minimum. So the graph of negative cosine x look like that. So that is 1 period. Copy and paste throughout the whole number line. So it's not that bad, right? Just determine amplitude and period, and it will just fit the graph inside, depends on the parent, sine, cosine. So that's why this is very important. When we know this, we can have the graph. So Now we just add more and more to it. Next, when we have different amplitude. Now when we have the period, by default, sine, cosine, secant, cosecant are 2 pi. If there's a number in front of it, the period will be 2 pi divided by those numbers. So in this case, let's do the same thing. Amplitude, there's nothing in front of it, right? So the amplitude is equal to 1. So the graph is bounded by 1. One up, one down. Now period. For a normal period, it is 2 pi, but since we have the coefficient of x, we take 2 pi for standard cosine sine divided by that number. So the period is just a pi. So if the period is just a pi, then we have to, again, divide a period into 4 equal segments. So that pi over 2 and pi over 4, 3 pi over 4. This will be 2 pi. Right, so I have one period here. And then the pattern of cosine is maximum, middle, minimum, middle, max, maximum, middle, minimum, then middle, max. So that's one period. Once again, I'll copy and paste throughout the number line. So that is y equal to cosine of 2x. Right? So the amplitude that will give us the bound, and the period give us what happened in the period. Of course, the pattern, we need to know that. Same thing on the next one. Amplitude just 1. One up, one down. Period. For sine, cosine, normal is 2 pi. However, we have the coefficient of x is 1 over 3. So we have to divide by that. Divide by 1/3 is multiply reciprocal. That gives us 6 pi. So we're going to have 6 pi. So between that will be 3 pi. And once again, divide into 4 equal segments. That gives us 1 period. And then the pattern of sine. middle, max, middle, minimum, and back to the middle, middle, max, middle, minimum, back to middle. You don't have to memorize this. Once you do enough problem, you can get the graph of sine, cosine. And also based on the even and odd, cosine is even, sine is odd. So cosine is symmetric on the y-axis. The sine is symmetric on the origin. So we see it is symmetric on the origin. If there's a point here, there will be a point across from the origin. So the point here, there will be a point across from the origin. So simple enough. When we can just combine the amplitude and period together, we can graph the function. Okay, here more example. Find amplitude and period and then graph this function. Now this is more interesting when we have both. So first, amplitude is absolute values of that number, and then period. The period normally is going to be 2 pi, but divided by the coefficient of x. So this is going to be 2. So the amplitude is 3. We don't have to draw in the right scale on the x and the y axis, so just choose something that looks reasonable. The increment on the x and y axis does not have to be the same. The period is 2. And divide into 4 equal pieces. So yeah, that's why I said you can choose 2 here on the x-axis and then 3 there. So like I said, it doesn't have to be the right scale, the same scale. 1, 2, 3, 4. Yeah. So whatever the period is, divide that into 4 equal segments. So that's what we have. And then we have one period is that window. Now the pattern for sine. Middle, max, middle, mean, back to the middle, middle, max, middle, mean, back to the middle. Right, and we'll just copy and paste. And stand throughout the number line. Right. Simple as that. Next we have this. Amplitude is the absolute values of that number, which is 2. Period. Normally for sine, cosine, this is 2 pi, but we have to divide by the coefficient of x. Divide fraction, multiply reciprocal. And then the pattern of cosine, whatever it is, we flip it, maximum become minimum because there's a minus here. So pattern of cosine is start from the max, middle, mean, middle, max. Now we throw in the negative. Pattern of negative cosine. Max become mean, middle stay middle, mean becomes max, middle stay middle, max become mean. I put all together, amplitude is 2, so let's say, yeah, we can just choose some numbers 2. Two up and 2 down. The period is 4 pi, so three pi. Yeah. 1, 2, 3, 4. Right. The next section will be a little more complicated when we have the phase shift. But for now, we just start from 0 and go 1 period. The pattern is minimum, middle, maximum, middle, minimum. So minimum, middle, max, middle, minimum. Even though I did not roll very well, the graph of course is not copy and paste exactly, but when you have those lines and then we know the increment, the point, in that case the curve where it fit into it, it looked very nice. Right, next we have secant, which is a lot more interesting. Now, when we have secant, we're not going to graph secant like that because the secant doesn't have amplitude. What we have to consider is the one that is reciprocal to this. So what we do is, instead of secant, first we're going to graph the reciprocal function. Still keep the negative 3 though. Give that secant, reciprocal of that is cosine. So once we can graph this, we can graph the secant. Right, so for this function, what is the amplitude? By the way, the characteristic of secant and cosecant, it will bounce off the maximum and minimum cosine. So we might want to consider that in the graph. Amplitude for this function, now I'm only talking about the cosine function, negative 3, which is 3. Once again, I said the graph bouncing off the maximum and minimum, so we don't want to say the 3 here, then we don't have any room for the graph to bounce off. So choose. Yeah, I choose 3 here and negative 3 here, so when the graph bouncing off of that, it will look more reasonable. Amplitude for that function, period for that function. Normally it is 2 pi, but we have to divide by the coefficient of x. So this is a pi. So 1, 2, 3, and 4. So that's a pi. So there's a period. and the pattern of negative cosine. I'm just going to copy from there. Minimum, middle, max, middle, and mean. So minimum, middle, max, middle, mean. And now copy and paste this. Throughout the number line. Right, so that is the graph of y equal to negative 3 cosine of 2x. The graph in the middle. Now, we're going to graph y equal to negative 3 secant of 2x. So how do we go from that? First of all, when we have the reciprocal function, when it is equal to 0, there will be the asymptotes. So asymptote will be where it is equal to 0. Right. So where the function equal to 0, reciprocal of 0, 1 over 0 is undefined. So that's where we have the asymptotes. See. Okay. So now the graph of y equal to negative 3 secant of 2x will be bouncing up the maximum and minimum and approaching to the asymptotes. So this is the graph of negative 3 secant of 2x. Right, the one, not the one in the middle. Then we can just erase kind of partial in the middle. Yeah. So that's what we have. Right. Of course, if we want to check, if we're going to use the calculator, make sure it is in the radian mode. And I'm going to put negative 3. Cannot do cosine, but we can do 1 divided by cosine of 2x. Right, so we have that. Now this is here from negative pi to pi. If we want to change that, hit Windows, from negative pi to pi, the increment is going to be pi divided by 4. And then you can see the graph between negative pi and pi. Right, exactly what we have. Right. Now about tangent and cotangent. For tangent, cotangent, the amplitudes, there will be none. And we only need, okay, let's say, for tangent and cotangent, the amplitude will be none. That doesn't help. The period. The period for normal tangent and cotangent is a pi. If you want to rewrite this, you can write as -2 tangent of 1/2 times x. So the coefficient of x is 1/2 multiplied reciprocal. So it's 2 pi. Period is 2 pi. Then how do we graph it? Right. Consider. So the period is 2 pi, right? Yeah, so that much we know. Let's say 1, 2, 3, 4, 2 pi. Half of that pi. 1, 2, 3, 4. -2 pi. -pi. Right, how do we graph this? Now consider tangent is equal to cosine. I mean sine over cosine, right? So I put that somewhere. Let's say tangent of something is sine over cosine. So where cosine is equal to 0? Yeah, we can write this as tangent of 1/2 x, but we don't even need that. So what is the pattern of cosine? Or negative cosine for that matter, it doesn't matter. Max, middle, mean, middle, and then max. And then pattern of negative, this one we have the negative. Max become mean, middle still middle, minimum becomes max. Max is mean, middle is still middle, max is mean. Right. What we focus on is wherever this is in the middle. Will be the same, right? For whether it's cosine or negative sine. So it will be here 0 and here it is 0. Right? That could be wrong. Remember, this is the tangent of 1/2 x. So if we have to rewrite this, it should be sine of 1/2 x cosine of 1/2 x. So the middle is not going to be those two, right? Because the function here is for cosine of x. This is cosine of 1/2 x. That is different. So we have to go back to see that table here. So for tangent, cotangent, just need to know where is cosine equal to 0. So when cosine equal to 0, where the function is undefined. Cosine equal to 0 is going to be this pi over 2 plus k pi. So we have 1/2 x equal to pi over 2 plus k pi. Right? That will give us the asymptotes. Never mind, this might not be as helpful. Because that is cosine of x, we have to focus on the cosine of 1/2 x. So the asymptote is where the denominator equal to 0, cosine equal to 0 when the angle equal to pi over 2 plus k pi. So that's what we have. Multiply 2 on both sides. X equal to pi plus k pi. So the value is equal to 0 is going to be, 2k pi equal to pi and negative pi, actually. Yeah. So tangent and cotangent, find where it is equal to 0. That gives us the asymptotes. And this is plus 2k pi, or the period is 2 pi, so this will repeat for every 2 pi. So find out where the bottom equal to 0, where the, in this case, cosine equal to 0 is pi over 2 plus k pi. The angle though is 1/2 x, so that's why we have 1/2 x equal to that. That gives us the asymptotes. Once we have the asymptotes, notice that tangent is decreasing. So when we know that, it will be easy. From the asymptote to the asymptote, tangent is increasing, right? Right? But actually correct. So tangent is increasing with the negative tangent is decreasing. So yeah, because this has the negative, so that's why it's decreasing. From asymptote to asymptotes. We can graph -2 tangent x over 2 it is decreasing, of course. And earlier we said it is the windows from negative pi to pi, so from one period it looks like that. So for the tangent or cotangent, this might be helpful because that gives us the 0 in the middle, but like I said, that doesn't help when it is something else. By something else, I mean this is cosine 1/2 x. So look at the pattern. This is going to be increasing with the negative. We make it decreasing. So normally tangent is increasing, but with the negative, it's going to flip upside down. Maximum become minimum, minimum become maximum, and increasing become decreasing. All we need to do for tangent and cotangent is figure out where it is equal to 0. I mean where the bottom equal to 0, where the asymptote is, where the function is undefined. That's where the function is undefined, meaning the bottom equal to 0. And we find those zeros, those are the asymptotes. Then we just is whether increasing or decreasing. We're going to fit the graph of tangent into that. All right. Next, simple harmonic motion. So in this case, a simple harmonic motion is given by a period with different period of 2 pi over whatever coefficient of the function, so that omega, so 2 pi divided by omega, so that is the period. The amplitude, of course, the absolute value of that number. So there's nothing new here. The amplitude, of course, absolute value of that number. The period for sine, cosine, take 2 pi divided by the coefficient of that. Now, the question is, can we base on that and determine what is the function if we have the graph? So on here, we know the graph bounded from 2 and -2. So from here we know the amplitude is 2 because it is bounded between -2 and 2. This case is 2. And the period, within one period, this graph copied and pasted to the whole number line. So the period is equal to 4. Right? That's what we have from this graph. And the pattern, middle, max, middle, mean, and back to middle. So this looks like a sine, right? Sine of something. So now put everything together. And this is positive sign also. So we have y equal to sine of something. Now just put in the information in. The amplitude is 2. There's no negative sign here because that is the sine x. If it go from like this, if it go from middle to the minimum, that would be negative, but there's none. Right, the variable, let's be x. We're going to have some numbers here. That could be omega, or that could be b. And the period for this problem, whatever b is, have to be equal to that. So the period, if it is for this problem, the period is going to be equal to 2 pi divided by b, if this is the function. Now all we need to do is matching those two together. Two pi over b is equal to 4, right? Cross multiply, 2 pi is equal to 4b. Divide by 4 on both sides, so b is equal to 1/2 upper pi. 2 pi over 4, or b is equal to pi over 2. So we will have the function is y equal to 2 sine pi over 2x. If we want to make sure, we can always graph it. Oops. Y equal to 2 sine, just clear, 2 sine pi over 2 times x. I'm going to change to the standard Windows. Zoom number 6. Right, you see a period is 0 to 4, right? And the maximum from negative 2 to 2. So that works. So just based on the amplitude and the period, we can deduce the problem. So from here, the amplitude from negative 3 to 3, so amplitude is 3. The pattern though, from 0 look like this will give us 1 period, right? Copy and paste. Because it go from 0, that this look like the graph of negative cosine. Cosine start from maximum to 0. So this is the graph of negative cosine. Right? Because cosine start from the maximum, sine start from 0. So if start from the minimum, it has to be negative cosine. Period. In this case, it's going to be 0 to pi, which is the length is equal to pi. Now put all together, the function will be y equal to a negative cosine of something x. And we know that the amplitude is 3, so we're going to put 3 in here. Still negative, because the now for this function, the period is equal to 2 pi divided by b. Now we're going to match pi and 2 pi over b. Cross multiply, b pi equal to 2 pi obviously cancel, divide by pi on both sides, b is equal to 1. Sorry, b is equal to 2. Divide by pi on both sides, b is equal to 2. So because of that, the graph is y equal to -3 cosine 2x. So the amplitude easy to determine. The pattern start from the minimum, so it has to be negative cosine. And just need to determine the period. The period in this case, it is a pi. And normally when you take this form cosine bx, the period is going to be 2 pi divided by b. We just need to solve for b. Once we know b, put it back into the answer, and that's what we have. Right, so that's all we have for this section 4.2. We use the amplitude and the period to graph. Most importantly, we did review and kind of all the important things we put together in this case. So this is a very good review for pretty much the whole chapter. But other than that, I'm going to end the video here. As always, thank you for watching, and see you in another video in trigonometry.